Hello, in this video we're going to cover sort complexities. We're going to go over the time/base complexity for every sort. The first sort we learned about, the bubble sort. If you remember, it just swaps each element, takes the largest value, it swaps each element such that the largest value ends up at the end, then swaps it again, swaps over and over again, until we have a fully sorted array. Okay, so it's best, we'll do time complexity and space. So it's time, let's go something like this. I'll do our best, average, and then its worst. Boop, boop, boop. So its best is O of n. Now, of course, there's an asterisk attached to this. Its average is O of n squared, and then its worst is O of n squared. So what is this asterisk about? Well, this is only true if you have a flag. Flag needed in implementation. Let's make that like this. And array pre-sorted. So what that means, like the array is coming to you sorted. Is entering the algorithm sorted. Okay. And everything else is pretty traditional. A bubble sorts are nested for loop, so that makes sense. Your space complexity is gonna be O of 1. Your average is O of 1. And your worst is O of 1. So that is bubble sort. So let's move on to selection sort. So quick refresher on selection sort. We find the minimum value in the array and we essentially just swap that with whatever value. So wherever that minimum value we find is that index, we take that index and we swap it with whatever is at the first unordered element. That is selection sort. So it's, and we just keep doing that over and over again. Its time complexity is has the best of O of n squared. It has an average of O of n squared. It has a worst of O of n squared. For space, there's a little sliver there. I'll make it a bit bigger though. So I'll make it a bit bigger, not a bit smaller. He's fine. Sorry. There you go. For space, your best is O of 1, your average is O of 1, and your worst is O of 1. Because same with this, you're just working with an array. You're not really adding, I don't think, much to the call stack. I can't really explain space too much right now because I don't understand, I'm not too into it as I understand time more than space, but you should be watching this after my time space complexities video come out. I recommend watching that video because of a big O and stuff before you jump into sorting. Let's talk about insertion sort next. Insertion sort is basically like these values that come before the current value we're looking at. Those values are bigger. Push those values up, and then in the blank space or the duplicate first instance of the duplication, just fill in the original value there. Okay, so that's gonna have a best time complexity of O of, I think it's n squared. No, I actually think it's O of n. No, it's definitely O of n. Average is O of n squared, and then worst is O of n squared. Insertion sort is like the best of the sorting algorithms. No, it's the best of these three sorting algorithms. The space O1, I call them space O1 sorting algorithms. Because they think they all share. times space. But what is color called it apart the space O1 sorting algorithm. So it's gonna have a space of O1 for its best, a space of O1 for its average, and then a space of O1 for its worst. Let me write that in. And then worst is O of 1. Okay, cool. Let's move on to the first recursive sort, which is the merge sort. Hopefully you guys found merge sort interesting. I actually find it interesting now that I understand the implementation fully. It's not as fast as quicksort because of its space complexity, or quicksort is a little bit better space complexity overall. Um, Looking at time, its best case, it can provide you with n log n. So the thing is with merge, yeah, and I got this wrong. I said this was on. I was thinking of insertion sort. That's my bad. In the actual video for merge, I said this. I said best was on. No, it's on log n. For merge sort, everything is on log n. N log n. We explained why this was the case. Recursion gives it that log n, and then it's n because we call it that when the merge function runs, it like loops over the elements n times. Well, no, it just the for loop in itself is n because you loop through every element. That's what I mean. Not loop. If you loop through every element n times, that's a net n squared. And it's moving on to space. So it's going to have a time complexity of O(n) for all of its cases. And its worst is O(n). Okay, moving on to quicksort. It's kind of crazy because this one video this today. I mean, I imagine you didn't watch them all today. I probably would. It's just a lot of content to condense. I feel like if I was approaching this, well, I did. I approached this like pretty much before. Started this week or 2 days ago. I started looking at these sorting algorithms. So of course I still have looked at them in the past, so I'm not like totally new to all this. Anyways, quick sort. Sorry, no side tangent and ranting. It's gonna have a best time complexity of n log n. So it's like, okay, you're quick, but you have the same best as merge sort. In fact, its average is also n log n. I'm gonna fix that a. I don't really like it that much. Not gonna delete that. Replace. Yo, why is my mouse tweaking? Yo, why are we tweaking, bro? Okay, cool. Okay, anyways. Let's do worst now. Now, worst is unique. It's kind of ironic because it's quick sort, but its worst can be elephant squared. It's like, okay, bro. Whoever named you quick sort is a liar, bro. Liar, pants on fire. Like, what is this? This occurs when your elements are pre-sorted. So if you pass in one array is pre-sorted. Okay, cool. Now moving on to space complexity. So best is O of, let me think, I think it's O of n. Its average is O of n log n. and its worst is, so its best is this. Okay, so it still is better. Oh no, I guess my thinking was right there. I was kind of messed up what was better. O of n log n. Okay, so this it should be like this. My fault, my fault. Again, I'm still learning with time and space complexities. But luckily I have my resources to help me. Okay, yeah, this is right. Let me check. Yep, everything is right. Good, 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 good. Swap those two things around, my fault. I apologize for that. Moving on to radix sort. Or did I explain? I didn't explain quicksort. Oh. Quicksort. Oh, I didn't explain merge sort either. Okay, what am I doing? I have to give little summaries here. Merge sort. You break your array into little elements, into this individual elements, and then you merge them back. You break them apart recursively, merge them back recursively. When you're merging them back, you sort them as you merge. Quicksort is you pick a pivot point. You sort your array into that pivot point. Get that you basically sort that array such that the pivot is at its correct location. Then you partition the array, split it into two. Your left array is all the values before your pivot. Your right is all the values after your pivot. And you just do your average freaking divide and conquer algorithm, which keep on calling this, keep on partitioning, keep on going like that. You'll eventually have every single element sorted. Radix sort is you just sorting by your least significant digit to your most significant digit. That's it. You can do one sort with your least significant, then your next least significant, then your next, all the way till you get to your most significant, and that's it. Okay, radix sort is, I think radix sort is the best for time complexity. It's unique. The name's unique, time complexity is unique. It's all O of n plus k, so it's best, average, and worst is O of n plus k, and its worst is O of n plus k. And its base complexities are going to be O of n. I hope I mix them up. Yeah, I'm a doo-doo brain. Or actually, we could just do this. Sorry, I'm tired, guys. I've been recording sorting videos for like 3 hours now. My brain is cooked. Let's push space up here. Let's take you, put you back where you belong. Into space. Now your best for time is O of n d. D for digit, I think. A is also O of n d. W is also O of n d. Or yeah, so your best, average, and worst. Best, average, and worst. And these you can write them all as O of n if you would like. They kind of also simplify the O of n. I mean, but this is the more formal way. These all simplified O of n in the grand scheme of things because n is just the most significant term. Alright, so let me just quickly go through, make sure I did everything right. That was from memory. I had to check here. As you see, I even got something wrong. I had to check quick sort. You're right. Okay, cool. Cool. You're right again. Cool, cool. Yep, this is all good. Moving on to merge. Merge. Oops, skipped it. Merge, yep. That's all good. That's all correct. Quick. This is all good. This is all correct down here too. Oh, so that's actually kind of nice. I think the easiest way to remember merge actually, or quick, is n log n, n squared for time, n log n, n for space. But n log n comes first for best, average, worst. That's a nice way of remembering it. N log, you can look at time as it's all n log n and all n. It's just in short, it's all n squared except for the best. And then space, remember I call these the space O1 because they all have the same space of O1. But the source, you can kind of view as O1 squared. Let's be real here. It's only O1 if this is met. Otherwise, it's O1 squared for best. And its Lexi source also O1 squared. But yeah, thank you for watching. Thank you for watching the short videos. All right, and bye.